This video is on arithmetic sequences. We are going to do the explicit form in this video. The last video was recursive form. Recursive form of arithmetic sequences is like the now-next form of linear equations. The explicit form is like the slope-intercept form of linear equations. We still need to know a sub n, a sub 1, and the common difference. The difference between recursive and explicit is we no longer use the a sub n minus 1, but we are still using n minus 1. We can rewrite this as, so we have a sub n equals a sub 1 plus n minus 1, all of that times d, or we can say it as a sub n equals a sub 1 plus d times n minus 1. D is the coefficient. It is the number that is multiplied towards your n minus 1. So if we look at this example, 7, 10, 13, 16, we want to write the explicit rule. So we still need to know what our a sub 1 is and our common difference. This is, as always, a sub 1 and our common difference. A sub 1 is the very first term, and because there are no ellipses in the beginning, we know that 7 is in fact our first term. Then our common difference means how do we go from one number to the next with addition or subtraction. We can see that we are adding 3 each time. So our common difference is equal to a positive 3, so we're adding 3 each time. So to write our explicit rule, we write out a sub n, because that's the value that we're wanting to find, is equal to our a sub 1 is in fact 7. Then our common difference is a positive 3, so we're going to put plus 3 times, and then we keep our n minus 1. This is our explicit form. Now the reason we want to know explicit form is because we don't need to know the previous term, that you can use it to find any term. This is very similar to y equals mx plus b. If I know the slope and y-intercept, then I can plug in any x value to find any y value. Same thing for this one. I can figure out what the next term is by just adding 3 every time. But here, if I want to know the 13th term, I don't have to keep adding 3. I could plug in 13 and figure out what I want. In this case, we can also write this as slope-intercept form. So I'm going to write that out. We can also write this, so this can also be written as slope-intercept form. Just like we said over here. If we wrote this as slope-intercept form, we have to know what our slope is, and what our y-intercept is. Our y-intercept is not the same thing as a sub 1. The y-intercept, to make a little note, is a sub 0, because it's when the x value is 0. We have a sub 1, so we actually need to know the term that would technically come before our 7. So if we write this out, we'd have a sub n equals 7 plus, we could distribute this, we'd have 3n and then minus 3. So if we simplify this, we'd have a sub n is equal to 3n plus 4, which would be written as y equals 3x plus 4. This would be slope-intercept form. We still have our slope as our coefficient, but our y-intercept would be a sub 0. There were no ellipses here, so yes, a sub 1 is 7. 7 is your first term. But if we technically wanted a sub 0, we could use that pattern of, instead of adding 3, we could go minus 3, and that's how we could technically get our y-intercept. That's if we were asking to write it in slope-intercept form. We were asked to write the explicit rule, and that's what we've done. But you can see how it can be written in slope-intercept form by distributing the 3. So using this explicit rule, we're going to use this explicit rule. we're going to find the 23rd term. We do not have to actually find the first, second, third, fourth, fifth, sixth, seventh. We don't have to keep counting. We can actually say that our term is 23. So this would be n would equal to 23, because that's our term that we want. We want a sub 23. So we'd have a sub 23 is equal to 7 plus 3 parentheses. Since we rewrote the n as 23, we write this n as 23 minus 1. Now we're going to simplify using order of operations. We would have 7 plus 3 parentheses. 23 minus 1 is 22. Then we would multiply, so we'd have 7 plus 3 times 22 is 66. And then we would add the 7. So a sub 23 is equal to 66 plus 7, which is 73. So instead of having to add 3 over and over and over again until we got to the 23rd term, we can plug it into the explicit, which is different than the recursive. In order to do the recursive, I would have had to have known the 5th, then the 6th, then the 7th, all the way up until the 22nd, and then I could find my 23rd term. So our last example here, it says, given a term and the common difference, find a sub 1 and write the recursive rule. So we're given the common difference, and we know what the 12th term is. So that will help us using this explicit. So if we use the explicit, that will help us. So plugging things in, we know that a sub 12, so we know the 12th term is equal to 28.6. So if we write out that the 12th term, so 28.6 is equal to, because that's our a sub n, is equal to a sub 1, because we don't know that value, plus, we know our common difference is 1.8 or 1 8/10 times, well, if the 12th term, if this is replacing our n, then the 12 also has to replace this n as well. So we'd have 12 minus 1 inside the parentheses. So we can now solve for our a sub 1. Because remember, we only need our common difference and our a sub 1 to be able to write out our equation, or to write out our recursive form. That's what we need. So let's solve for that. So we have 28.6 is equal to, or 28 6/10 is equal to a sub 1 plus 1 8/10 times 11, because it's 12 minus 1. So we have 28 6/10 is equal to a sub 1 plus 1 8/10 times 11 is 19 8/10. And now we want to subtract 19 8/10 from 28 6/10. So we end up with a sub 1 is equal to 8 8/10. So we have a sub 1 is equal to 8 8/10. Now that we have both of these values, we can write our recursive rule. If we remember recursive rule, the recursive is a sub n is equal to a sub n minus 1, so that's really next equals now, plus your common difference. Then we need to know what our a sub 1 is, so starting at. So our next, which we don't know, we're going to write it as a sub n equals our now, a sub n minus 1, plus our common difference, which was plus 1 8/10, semicolon, so starting at our a sub 1. So a sub 1 is equal to 8 8/10. And this would be our recursive rule. From the explicit, we get the a sub 1, our common difference, and then we get our a sub 1. Then once we have both of them, we can have our recursive and our explicit rule. We could even now write our explicit rule if we wanted to.